Before we can answer question 15, we need to just check our understanding. When I have a nucleophile like ammonia with a lone pair on it, it's a lone pair donor, it attacks the delta plus on the C of a polar bond. Br minus is slightly negative, delta negative, because it's electronegative and draws the electrons towards itself along the covalent C to Br bond. And that allows this nucleophile, this ammonia with its lone pair, to bond to the C, and the electrons from the CBr move on to the Br minus, it forms Br minus, and then you end up with an N bonded to the C with 3 H's. There's a plus on the N because it's donated electrons, and then an H breaks off. The electrons go from one of the NH bonds onto the N, removes the H plus, and removes the N plus, and makes an H plus. Nucleophilic substitution. However, what you've made, ethylamine, has also got a lone pair here on the N, so this ethylamine can react with the bromoethane again, and therefore that N can lose another H and get another ethyl group, and then it can react again and lose another H and get another ethyl group. In other words, ethylamine can turn into diethylamine into triethylamine, so convert from a primary amine into a secondary amine into a tertiary amine, and this triethylamine with a lone pair can attack that C again and actually get 4 ethyl groups. This time it ends up with an N plus. It can't remove the plus because there's no longer any H's to break off and move the electrons from an NH bond and remove the plus. So it makes this kind of compound called a quaternary ammonium salt, which is used as a detergent. Let's have a look at the question here then now. I've got C9H21N is produced from reaction 2. So let's have a look at reaction 2. So reaction 2 involves propylamine being made, propylamine here, from 1-bromopropane. So once you've actually made this, the NH3 reacts and replaces with nucleophilic substitution the Br, and you make this. Now this has got a lone pair of electrons on the N. The N can react again and replace this whole group, then can replace this whole compound, can replace the Br 3 times over. So it can create an N with 3 propyl groups on it, 3 CH3, CH2, CH2s. So it keeps replacing the Br once, twice, 3 times over. So what you actually make is an N with 1, 2, 3, with a CH2, CH2, CH3, CH2, CH2, CH3, CH2, CH2, CH3. And it's actually S for the skeletal formula, so you need to draw it in this way. Functional group including classification. It's got an N, so it's an amine. It's not an amide. An amide has an N bonded to a C double bond O. It's an amine, and it has 3 carbons bonded to the N, so it's a tertiary amine. So if we go back here, we've got a primary amine with 1 C joint bonded to the N. We've got a secondary amine with 2 C's bonded to the N, and we've got a tertiary amine with 3 C's bonded to the N. So it's a tertiary amine. Identify the reagent and the conditions used in reaction 3. So in reaction 3, let's look back at reaction 3. Reaction 3 here, the Br has been removed and I've now got C3H6. I've got a double bond. So this is the reaction that I talked about before. Instead of using sodium hydroxide in cold water, you've used sodium hydroxide in warm ethanol, and it's reacted with an H from this CH2 here, removed it. The CH, the electrons from the CH have moved between the 2 carbons to make a double bond, and the Br has been eliminated. So you've got an elimination reaction. Let's have a look at the mechanism here. It's a little clearer here. The OH minus, instead of replacing the Br and attacking that C delta plus and the Br coming off, it goes from the Br to the C to the next C, and it attacks one of these two H's here. It attacks that H and will form water, H2O. The minus has gone because electrons have moved away from this. This is acting now as a base and removing an H+. The electrons move in between the two carbons, and the electrons move from that bond, that CBr, and it breaks the bond. It's an elimination reaction because water is removed from using that H+ there, and a Br is removed, so this molecule becomes smaller. It's an elimination reaction. Identify the reagent used. So the reagent used, as I've said, is sodium hydroxide again, or potassium hydroxide, but this time it's in ethanol rather than in cold water.